Okay, we're going to take a look at problem 1.4.35. And so what we're looking at here is you're given some data. Here's your data table. Here's your weight of the cars and the miles per gallon. And so we want to see if there's a relationship between those two. And so for this graph here, we have this here. And what it's saying is with this original data here, what would happen if we added car 12? What would where you have 3305 and then 19 miles per gallon, thinking there's going to be a relationship between these, the weight of a car and how many miles per gallon, and it looks like there is just by the inspection of the graph. This is the correct answer here. The more a car weighs, the less miles it gets per gallon. And so what we're going to do here to calculate the correlation coefficient to verify that, we would open that data in StatCrunch. And then we're going to add the 12th car. So this won't be done by hand. Let me finish that up. This won't be done by hand. So the 12th car we have is 3305. And it gets 19 miles per gallon, and that's car 12. And then we're going to run the regression. Simple linear. The other thing, again, you could do is run summary stats correlation just to get the correlation coefficient, right? You could run that on weight and miles per gallon, compute, and then you get the correlation coefficient. So that's one way to do it. The other way is to run a regression, simple linear, the weight, and then the miles per gallon. Weight would be explanatory, miles per gallon would be response variable, compute, and then you end up with your correlation coefficient again, negative 0.945 or negative 0.95. Since it's close to 1, we can say we have correlation. Again, we could also compare it to the critical value table when you're given one. And so now that we have that, that's how you would calculate the correlation coefficient right here.